When you think about it, all those devices we do have in our environment every day in our homes. That means there's many, many more devices per station or per access point. And Wi-Fi 6 brings significant advantages to deal with that more crowded environment and still give a very robust and reliable experience to the end user.
More devices throughout our homes, buildings, and cities are connected to the internet. Today, we'll learn about the role that Wi-Fi 6 plays in this connectivity with our guest from Texas Instruments. Hello, this is Martha DeGrasse here again for the Wi-Fi Alliance, and this is The Signal, our podcast where we bring you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. In this episode, we are super excited to talk about the role of Wi-Fi 6 in the industrial IoT with Marian Kost. He is VP and GM of Connectivity at Texas Instruments. Welcome to The Signal, Marian.
Thank you so much, Martha. Great to be here. Thank you.
It's great to see you in your own studio. It looks like TI has quite the setup there in Dallas. I haven't had a guest with this much equipment before. It's pretty exciting.
I appreciate that, Martha. Yeah, it's very important, obviously, to speak loudly to the world about what we're doing. It's very convenient to have the studio. You're absolutely right.
We're expecting great things. Okay, let's just start off with a big picture overview of what Wi-Fi 6 means for TI's microcontroller business.
Yeah, we are extremely excited about the new Wi-Fi 6 standard 802.11ax, and specifically in the industrial environment. TI Connectivity, we have been designing industrial IoT products since more than 20 years. Industrial IoT is really just at the beginning and just evolving. What it really means, what Wi-Fi 6 bottom line brings us is it allows us to have an improved performance of IoT products in very dense environments. And that's exactly what will be the most important thing in the future, as there will be more and more nodes added to existing networks and new networks will be established. So it becomes more and more important to guarantee a reliable and robust working experience of Wi-Fi as we're used to have it. As those nodes are increasing in environments, we get into more dense environments. And that's where Wi-Fi 6 makes a fundamental difference. And that's why for us, we are taking the Wi-Fi 6 standard and building technology that can take advantage of that great standardization that Wi-Fi 6 brings to the industrial world.
That's great. What are some of the IoT applications that are going to drive this densification?
I think when you look at the application scenarios, you can see that in multiple different sectors. Right now, we see that there's more and more electrical vehicles being deployed, and we use them every day, and the world is becoming greener. Now, that also means there's a lot of EV charging stations. Now, we all need to have information how is actually the energy being used by all those new applications. In order to do that, we need to understand what's actually happening at the charging station as one example. Now, there's wireless connectivity, brings those data points to the backhaul. And Wi-Fi is a very perfect technology to do that because the install base, the infrastructure is already existing. Equally so, let's look into the medical environment, the telehealth and the health care at home, where I'm taking advantage of the existing Wi-Fi infrastructure and can now very securely connect more, for example, patient monitoring systems into the network in a secure manner. So it will add more Wi-Fi nodes there as well. Additionally, what we're seeing is Wi-Fi is being added to home appliances. Every one of us uses more and more Wi-Fi devices with our personal electronic devices as well. But we're also seeing Wi-Fi devices being added, for example, to HVAC units and to electricity meters. Again, I mentioned EV charging stations, to the appliances. So when you think about it, all those devices we do have in our environment every day in our homes. That means there's many, many more devices per station or per access point. And Wi-Fi 6 brings significant advantages to deal with that more crowded environment and still give a very robust and reliable experience to the end user.
For your devices, your chips, are they similar across all those different applications, or do you have different SKUs for the different applications that you just named?
Yeah, that's a very good question. So typically we are working on family development of devices, and families in multiple aspects. Our ambition is with the industrial IoT and industrial Wi-Fi that you can add Wi-Fi in an easy, simplistic, but very robust manner to any type of embedded system. Depends on how you build your embedded system. what operating system it is using, if it's an MCU-based system or maybe a processor-based system with more horsepower. We try to build devices in a very easy way to attach Wi-Fi and enable Wi-Fi connectivity without disrupting the existing system. Because many of the applications that I mentioned, those are applications that exist today or where the main focus of the development is not around the connectivity. So the connectivity needs to be a subsystem that can be added and is secure and reliable and that I can trust. This defines how we build our devices. So we do have fully integrated wireless MCUs that support Wi-Fi, and we do have what we call companion ICs that can be attached to existing embedded infrastructure systems.
Is that your Simple Link?
All of them fall under our Simple Link brand name. That's what we call the Simple Link, to establish a simple, robust, reliable link, taking advantages of the standard.
Okay, great. Yeah, I think you make a good point. A lot of times connectivity may be almost an afterthought for some of these designers, and yet they couldn't move forward without it. So you have to be ready, right?
That's right. And you also want to take off the complexity. I mean, the technology is very complex. That's what makes the standard actually great and very robust and reliable and also secure. But you don't want to have the developers being occupied his thoughts with all the details that need to be taken care of. So it's very important to establish an infrastructure. So for example, if you have a Linux-based system, you want to have a driver infrastructure that is proven and that can enable you to simply enable the full advantages of Wi-Fi within your system quickly.
That's great. What operating systems do you see the most of? Do you see a lot of Linux?
We do see Linux. I mean, Linux, of course, is running on processor-type devices, so it's sometimes bigger devices or HMI, human-machine interface type of devices that do also more computation. But we also see actually a lot of RTOS or of real-time operating system-based systems, which are more MCU-like. For us, we actually just built a device family with Wi-Fi 6 that allows you to attach a Wi-Fi 6 IC to an MPU equally as to an MCU. So we are providing the drivers for an RTOS-based system as well as for a Linux-based system. So we want to give that flexibility and then basically hide the complexity within the device itself and also provide the Wi-Fi stack itself and the components for the stack.
With a lot of the movement of data from these connected systems and applications, it's likely not going to go all the way back to the cloud. It's going to be processed somewhere a little closer to the edge. Is that what you expect?
Yeah, we see that in many places. I think Wi-Fi 6, of course, gives a lot of capability to increase also the throughput, meaning it can be more data being sent through the channels because of the more efficient use of the spectrum, which Wi-Fi 6 enables as a standard. However, we do see that a lot of data has also started to be processed more on the edge. And actually, in many, many cases, and that's why we call it like Wi-Fi for IoT, smaller throughput is actually way good enough. We see applications of where 5 megabits per second, 10 megabits per second, maybe up to 50 megabits per second can serve 95% of the more IoT-like applications. Again, if you need to have user data from an EV charging station, meaning how often is the charge used, how much was consumed, and so on, those are not huge amount of data. So you process the data format on the edge, and then you use the Wi-Fi 6 standard to really bring it to the cloud in a very efficient way. And that's actually a very smart way to do it because, back to our original point, now you can add many more of those nodes to the same network.
All right. What about like smart city, transportation, logistics, any applications like that Wi-Fi 6 is playing into?
Definitely. I think Wi-Fi 6 is rolling out across the cities and building on top of the infrastructure that is already available. Now it allows you very easily to attach additional nodes to those networks. And that's definitely in the logistics space. We see applications in the smart city environment. We see applications. I think a lot is, again, around the energy distribution and the rebalancing of the grid. We also see applications in the solar space, again, in the metering space. We see it in warehouses, where, for example, logistics systems, you track your tools and your components inside the warehouse, and you want to have that information back to the cloud in an efficient and very secure manner. So we see that in warehousing or in factories as well as then in the smart city concept.
Okay. What about safety, public safety, or even home safety? I was reading about your chamberless smoke detector application. I thought that was kind of cool.
Yeah, that's right. That's another very important space for us. We have been shipping a lot into what we would refer to as building security and safety type applications. And of course, there's today already deployed quite heavily IP-based camera systems that actually also, to your previous point, do some edge detection of objects or movements on the edge, but then you want to have that information in a very efficient manner back to the backhaul. We see that in public spaces, to your point, public safety and security. We do see that a lot in commercial buildings that become more safe for all of us. We see that in applications within schools and hospitals. So any, I would say, public or semi-public places where people are operating, we see a lot of data capturing happening that need to be transmitted safely back to the cloud or even to on-premise type systems, used Wi-Fi.
Okay, great. For the designers of these smart cameras, smoke detectors, whatever the devices may be, what are some ways to make it easier for them to work with Wi-Fi? You already mentioned companion integrated circuits. Anything else that TI can do to make it easier for them to add Wi-Fi?
I think what is also very important is to support the full ecosystem, and that means the devices need to work together with the processors that are being used, and they need to also come with certified Wi-Fi stacks that are developed against the existing standard, and they need to be compliant. It's very, very important that it's made easier for those embedded developers to get to a certifiable solution and a compliant solution quickly. So that, of course, has to do with, first of all, the software that is being delivered, but also to do with, for example, the RF performance, that you can pass all the radio frequency regulations around the world. And there's physical parameters that are important, such as output power that needs to be optimized. For example, receive sensitivity, which then defines basically your link budget. You want to have a very robust link budget within, for example, congested environment, as well as specifically in buildings. So there's a lot of things there. The other thing is we are very focused on integrating more of the components that you would need around the chipset to bring it into the device itself. So Wi-Fi 6, for example, enables multiple frequency bands. Wi-Fi 6 comes with the specification of using the 2.4 gigahertz spectrum as well as the 5 gigahertz spectrum. So how can you build a system that gives you flexibility to have a line of products that support 2.4 gigahertz, line of product that actually support dual band without changing the whole system all over again? So there's a lot of design considerations that are being done throughout the design of the IC and the total ecosystem to make it simpler to enable such a system development.
Okay, that's great. You haven't talked much about Wi-Fi 6E. You did say that a lot of applications don't require a lot of data or a lot of bandwidth, but maybe there are some that do. Is Wi-Fi 6E important to what you're doing or not so much?
No, I think Wi-Fi 6 is actually also very important. Again, Wi-Fi 6 gives the ability to actually extend the Wi-Fi 6 features to the less congested 6 gigahertz band. 2.4 gigahertz, of course, is a band that's being used for other technologies as well. We have Bluetooth Low Energy in that space. We have things like Thread and Zigbee in that space. There's a lot of proprietary systems in 2.4 gigahertz. Then you have the 5 gigahertz band, which gives you more flexibility and actually a higher number of non-overlapping channels, specifically in the 20 megahertz channels, which is those channels that are very well usable for the IoT space, not the super high throughput. And the 6 gigahertz gives you even more number of channels, non-overlapping channels in that 6 gigahertz band. So it's another extension of making sure that we can build future-proof, reliable Wi-Fi systems or networks, I have to say, with more devices being able to operate on those networks.
Okay, great. And what about research? Do you have any ongoing research in the area of Wi-Fi 6 or 6E that you can talk to us about?
That's a very good question. We are part of the Wi-Fi Alliance, of course, as you know, and we're always working together to also influence the standard and trying to find new mechanisms and new technologies that can enhance the technology even further and make it even more useful, always with this vision in mind to allow a better world with affordable electronics through semiconductors, or you can say affordable semiconductors, because if we can make those systems and actually build devices that will be even more affordable, then more and more people can take advantage of that technology that we talked about, a better security of the grid. And security, I mean, in terms of energy can be redistributed in a better way because now I have insights of what's happening. We enable better medical systems for patients. That is a huge value. And how can I do that? By gathering information about what's actually going on in the patient's homes. More secure buildings and more safe buildings, which is a huge value. So we're always working on new innovations and technologies that make those systems more future-proof. What I can talk to is we have been working a lot, and some of that is already reflected in just now launched new family of devices called CC33XX, but there will be more coming, so everyone can stay tuned, to make those devices much, much more cost-effective, highly integrated. We allow those devices to be built on our side in internal TI manufacturing flows. We put them into standardized packages that make it much easier to use them, much, much smaller, so you can integrate them into end equipments where normally you would not add a connectivity solution to it. So there's a lot of detailed background R&D work before we even start building a product. And we do have R&D centers and dedicated teams actually around the world in multiple locations solely working on the next generation Wi-Fi devices. So everyone can be excited about what's coming.
All right. Now, I think that TI was also one of the early proponents of Matter. I think maybe you had one of the first working demonstrations. Any updates on Matter? Are you doing anything new there?
Yeah, Matter, we have been very excited to work on this project with many, many other industry leaders. It was a long journey that led up to releasing actually the standard just recently in the first quarter. And yes, you're correct. Even before the official release, we had demonstration to showcase that the technology works. Now, actually at the launch, we showcase, for example, a Matter-enabled heat pump, which again goes back to optimizing efficiency in buildings. And we will continue to push the limits of that standard and enable our devices, not just the Wi-Fi devices, also some low power 2.4 gigahertz SoCs to support Matter, as well as we have contributed to the source code of the Matter standard actually from our side.
Oh, you have?
Yes, and we also have our internal TI Matter stack that we provide to customers, of course, free of charge, part of the hardware portfolio. So we will stay on the forefront there. It's going to be very interesting. We see a lot of interest across multiple different industries in terms of Matter. It's going to be interesting on how fast the adoption rate continues with Matter and how many people really take advantage of the capabilities that Matter can bridge between different ecosystems and technologies. So that's going to be very interesting.
Like you mentioned, a Matter-enabled heat pump. So like the heat pump would talk to the thermostat, or what would the idea be there?
Exactly, for example. And you would also see things like how is the heat pump being utilized, so before it breaks down or before something happens. You can even leverage it not just from an efficiency standpoint, but you can also leverage from a maintenance standpoint.
Which industry do you see expressing the most interest in Matter so far?
I would say home appliances that want to talk to other devices across the homes. That's from an end user perspective. And then again, we see it ranging into more, let's say, the commercial building space, where some aspects of maintenance and service aspects and also safety aspects come into play, where you want to basically tap into an existing infrastructure. And I think Wi-Fi gave us the best example. Wi-Fi in itself is the perfect infrastructure to do all these things. Now, Matter allows to talk between devices from different vendors. And that can be leveraging the Wi-Fi network and also some other networks, but predominantly the Wi-Fi network. Now you can talk, from one device vendor to another device vendor, and the end user doesn't need to make a choice. Oh, this company is offering me this wireless protocol, so I'll go with them. But now you can focus yourself on the actual performance of the end product, and the end product can talk to all the other end products from the other vendors. And I think that's a big benefit where we see commercial buildings and in-home buildings right now the biggest pull for Matter at this point.
Yeah, that makes sense. All right. Anything else that you want to make sure you update us on while you're here?
No, I think this is a great discussion. Again, we're excited about how Wi-Fi is evolving. Wi-Fi 6 is a true breakthrough for the industry, and then 6E, we're excited about that one as well. So yeah, I think it's on us now to really bring that technology to life and make sure every developer around the world can benefit from it with easier to use, more affordable, and more robust, reliable Wi-Fi 6 solutions.
All right, Marian Kost, VP and GM of Connectivity at Texas Instruments. Thank you so much for being here on The Signal.
Thank you, Martha. It was a pleasure meeting you and talking to you.
Yeah, it was great. And that is our show. Don't forget to check the show notes for more resources, and be sure to follow The Signal on Apple Podcasts, Spotify, Google Podcasts, and Amazon Music to get all the latest episodes straight to your device. For all things Wi-Fi, check out Wi-Fi Alliance. That's y-fi.org. I'm Martha DeGrasse here for Wi-Fi Alliance. Thanks for listening, and please join us next time on The Signal.